Hi, in this video we are going to discuss functional interface. Functional interface is a new feature added in Java 8. Functional interface can have just one abstract method. So this is what makes it different from any other Java interface. It can have only one abstract method, and I'm going to explain the reason for it a little later. However, it can have any number of default methods. Default method is again a new feature in Java 8. It allows you to have non-abstract implemented methods in an interface. You can have any number of default methods in your interface. But if it's a functional interface, then it can have only one abstract method, and this can be ensured by using the annotation functional interface. So if in your interface if you use this annotation functional interface, then the compiler is going to force you to have only one abstract method. We talked about lambda expressions earlier, and we mentioned that lambda expression is an object of type functional interface. So it actually implements the abstract method in functional interface. Now, one lambda can have only one method signature, and that's the reason the functional interface needs to have only one abstract method, because that's going to be implemented by lambda, which is going to implement that one abstract method. So let's go to Eclipse now to look at an example. So here I have a test class for testing functional interface. So what I have done is I have this calculator functional interface. It's using this annotation functional interface. So this is going to ensure that I can have only one abstract method. So currently I just have this one abstract method, calculate. And now let's see, let's try to add a second abstract method. So I can call it calculate2. But note here, as soon as I do that, I get an error. The compiler throws an error saying that this is using this functional interface annotation, so it can have only one abstract method. So that's the reason I'm getting that error. So let me get rid of that. So again, keep in mind that if you're creating a functional interface, then you can have only one abstract method. You can have any number of default methods. Default methods again are non-abstract implemented methods. So you can have any number of those. So I have a sum method, I have a product default method. Now for testing this functional interface further, what I have done is, so here I have the main method, and this is just the anonymous inner class implementing the functional interface the way we would have done it in the pre-Java 8, pre-Lambda days. So you would need to use an anonymous inner class to implement the interface. And so this inner class is implementing the abstract method calculate, and then from within the implementation is calling this default method sum. So this is how you could have implemented the interface and used it in the pre-Java 8 days. But now that we have lambdas, so instead of writing all this boilerplate code and all this anonymous inner class, you could simply replace that with a lambda. So that's the beauty of it. The volume of code is tremendously reduced, and it's going to achieve the same thing, which is just doing a sum of a and b. So let's look at this little more minutely. So what's happening here is So this lambda here, it's trying to implement this abstract method calculate here. So note that calculate has two parameters. So first thing, this lambda also needs to have two parameters if it's trying to implement this this calculator functional interface. Note that if I get rid of this parameter, immediately I'm going to get an error, because now the lambda expression signature does not match the signature of the functional interface. Note that I'm trying to assign this this lambda to this functional interface, and that's why it's catching this error. So another thing to note here is lambdas are objects of type functional interface. So this lambda, we are assigning it to this functional interface, calculator functional interface. So it has to match exactly the signature of the abstract method for this interface. So that's why we need to have two parameters here. The implementation can be anything. So in this case, it's simply doing a sum of a plus b, and that's why I called it sum calculator. We can also have a product, because the implementation can be anything. So in this case, I'm just multiplying a times b, and so here I call it the product calculator. So yeah, the interesting things to note here is the volume of code is greatly reduced by using the lambda, but the lambda has to match the method signature of the abstract method signature of the functional interface. So let's try to run this program. Again, what I'm doing here is when I run it, first I call the calculate method here. So here it's going to call the calculate method implemented by this anonymous inner class. In this second case, it's going to call the calculate method implemented by this sum calculator, which was assigned from a lambda. And in the third case, it's going to call the calculate method implemented here by this product calculator lambda. So let's go ahead and run this test. So as you see, in the first case it printed 5 plus 6, 11. This was done by the anonymous inner class. Second was one done by the sum calculator lambda, and this 30 was calculated by the product calculator lambda. So this was a simple example of how we can use lambdas for implementing the abstract method in functional interface. Of course, there is a lot more to it, but this was a quick introduction of functional interface. Thanks for watching this video.